Hello everyone, this is Aida Gholami from Arcmap Research Company. I'm here to teach you how to prepare the land use map for your SWAT model. Now the things I want to mention first is that you need some tools. The first tool you need is ArcGIS, and I use the version 10.2. And the next thing is obviously the satellite images, and I use Landsat 8 images. And the next thing is Envi tool, and I use the version 5.3. So the first thing you need to do is to go to the Earth Explorer USGS site and download the satellite images. Okay, you need to define your study area and the place you want to have the satellite image for, and I upload the shapefile usually. Then you need to specify the date of the satellite image you need, and for example I get like 2018 in the May, and go to datasets, and here you need to select the dataset you want. It's Landsat collection 1 level 2, and it's Landsat 8 OLI. Then go to the results, and as I have taught you before, you just need to see which images cover fully your study area and then download them. So these two are covering my study area. I download them, and now I have these two images here. When you download the satellite images, you get like something similar to this file. Okay, when you open it, you see different bands and different files here that I'm going to teach you how to work with them. First, open Arcmap. Now, while this is opening, I should mention that for this tutorial, you need to prepare two types of images. The first image you need to prepare is your natural color image, which is prepared using 3 bands. Here in Landsat 8 you have bands I think number 2 and 3 and 4, and the next image you want, and you want it for running the algorithm, for running the classification algorithm in Envi, you need an image which contains more bands. These bands include NIR, the natural color, NDVI, slope, and you need to stack all these bands into one image and use it in order to run the algorithm. I will clarify it later on. So the first thing you need to do is to open the, where it is, it's here in the images. Open this file, and you want to know which bands should you composite in order to have the natural color. So let's search it. Landsat 8 bands and combinations. There it is. So here you can see that natural color is numbers 4, 3, and 2. So I will composite the bands 4, 3, and 2. Okay. Now here you want to run the composite bands command. Okay, the input rasters will be bands 4, 3, and 2, and the output raster will be natural color or whatever name you want to put. And then I'm compositing the path number 159, so I will make it 159, and then I say natural 159. So there you see the composited band, and it's the natural color. I will do it for the next path and come back. Okay, now you can see I have the next image made, and there you can see it. But the problem here is that we have these black margins that if I mosaic them right now, these black margins won't remove. So I first need to run the copy raster command and remove these margins. Copy raster, and no data value will be 0, and the output will be here. Oh, click OK. And there it is, and I will do it for the next path. No data value will be 0. Okay, and then I want to mosaic them and clip them to my study area. Number of bands is 3. Okay. Okay, it's Mosaic, and I mask it to my study area. Input raster will be natural, and mask data will be this one. And save it. Okay, the image is mosaic, and the next step is to mask it to your study area. So first you need to open the study area borders. So okay, and then extract by mask. Input raster will be natural, and feature mask data will be the neighbor layer, and okay, it will get error. What about this one? Okay, and press OK. So now you have one of the images I mentioned earlier that you should have. The next image is the image made of NIR, natural color, NDVI, and slope. So let's make this another image. First, you want to add the NIR band, and NIR band in the OLI satellite is band number 5, but you can double check it here. Band 5 is near infrared or NIR. Okay, add band 5. Band number 5 and another image. Okay, now you want to mosaic it. Oh, but before that, you want to remove the black margins. So copy raster. No data will be 0 and press OK. Okay, the next one, do the same for the other image, and 159. No data will be 0 and press OK. Okay, next you want to mosaic it and mask it to your study area. Because I have done it earlier in this video, I will just skip this step and come back to you when it is done. Okay, you can see that I have the NIR mosaic and masked to my study area. The next band I need for making this image is the natural color, but I have made it right already. But another band that I haven't done is the NDVI. So let's make it together. For making the NDVI, you need to have bands NIR and red and NIR, and the visible red is band 4. So the thing I want to do is to do the same process for band 4 and then composite these two images. So I need to do the same process I did for NIR band for the band number 4, and I will come back to you again. Okay, now I have made this band 4 image. I mosaiced it and masked it, and now, okay, now in order to have the NDVI image, first of all you should composite these two bands and have one image which has two bands, and that's NIR and band 4. So let's composite bands, and input rasters will be band 4 and NIR, and then NDVI, and okay, save it. Now you can go to the Envi. Yeah, you should open Envi and then make the NDVI image. Okay, now open the band 4. I exported it to okay, now you should open the file you made. By the way, I forgot to export it to TIFF because Envi doesn't know the format that Arcmap uses. So you should, okay, NDVI. You should export it to TIFF. Now you can open it in Envi. Open. And then choose NDVI. And select the input file. Okay, and here band red. Okay, first you should choose input file type is Landsat OLI, and then it realizes that the red band is the band number 1 and NIR band is the band number 2. Output result to file and choose the file address. Okay, file name will be NDVI Envi. I'm sorry. Okay. And that's your NDVI image. Another band you need for making that image is the slope. So I have made the slope layer before and I have it already, but if you want me to teach you how to prepare slope image, let me know in the comments. That's the slope file. So I will export it and export it to TIFF in order to be able to open it in Envi. No data is 0. Save. Okay, now you should open all the layers I mentioned before in Envi. So I need the NIR, natural color, NDVI, slope. But the thing is that we have exported NIR, so it's ready to open it in Envi. So we have to export natural color image in order to open it in Envi. Okay, exported. Okay, you can open them all in Envi. And whatever you remove in here, if you want to remove it, remove it from Envi, not just from the layer manager, you can open data manager and remove it from here, close file. So now you want to have natural color image, and NIR, and NDVI is already opened, and slope. So now let's use layer stack command and stack all of them into one image. Import files and you import all of them. Okay. Don't change anything. Output result to file, and it's here, layer stack. Okay, and the projection is UTM WGS 84 and zone number 40. So, okay. and that's the image you want to inform to the algorithm and make the classification algorithm run. So we have right now 2 images prepared and ready to use. Now you want to open the first close all of them. Um, okay, and now open the natural color image. The next step is to collect ROI, and ROI is the region of interest, and they are the samples and training data that you inform to your algorithm and you like train the algorithm with. So click this option here, ROI, and click new ROI. Now, depending on your study, you can have lots of ROIs. And for example, here I want to just put 6 ROIs. The first one is crop. You can also create ROI with a polygon or rectangle or circle or whatever. I use rectangle. Okay, so zoom to your study area and you can see these like defined lands that have defined shape. And by that, I mean that pay attention to the differences between these areas and these areas and these areas. These are gardens. These are orchards. You can see the fluffy shapes here, but this is a flat, like defined. I don't know what's the word. You know what I mean. Just pay attention to the differences. Like here, it's center pivot lands, and I will choose these and I will collect these samples as my crop ROI. Make ROIs all over your study area. Don't focus too much of them or too less of them in specific place of your study area. Just have it all over the image you have. And another tip I want to mention is that you can see here there are different colors for these specified shapes of the lands. Here you can see the green lands, which indicates the growing season, and you can see that here the crop, whatever it is growing and it's green, and you can see that, and you can see it. But here it is also a crop field. It's also agricultural land. But in the time that this satellite image was captured, it didn't have any growing crop. But the thing is that SWAT doesn't care. SWAT wants all fields in your study area that has crop in any time of the year. So you want to select those lands also as the crop ROI. For example, I get here. I know that here is agricultural land, but right now it doesn't have any crop, so I get it in my ROIs. I get down my study area. Here I select these places. You can see, for example, here is a center pivot, and you can select this place, but not this one, because this is so you can see these are yellow, and you can see that it indicates that somewhere in the year it has growing plants. Okay. And another thing I wanted to mention is that be careful, pay attention, and put time. Zoom in, zoom in, zoom in, and get just these pure pixels. You can see this one or all these border pixels are mixed pixels. You don't want them. You just want pure pixels that are just indicating the ROI you're collecting. Okay, because this way algorithm works better and gives you the best results. And by the way, this is a very much time consuming process, and sometimes boring, but no problem. It's research and you want to go through it. Okay, because I just want to teach you how to do it, and I don't want to really run the algorithm right now, it's enough, but you note that um, like for this scale of study area, you want at least 100 or 200 samples, and you just can't stop working this soon. So get going to it. The next ROI I want to collect is garden. So I will write garden here, and I will choose the color for dark green and go to select ROIs. You can see here in the mountains, mostly in my study area, I have garden, and the difference between these places and the agricultural fields, as I mentioned before, is that they are like fluffy pixels that don't have any defined shapes. So I go to it and select RI. Okay, I also have gardens. Yeah, these places of my study area. Zoom in, zoom in, zoom in, and get the pixels. Okay, that's it. Another ROI is water, of course. So write water and choose blue color for it. You can see here I have a dam. So I go right into it and select ROIs. In my study area, I don't have much water. It's a arid and semi-arid region in Iran. So, like it's just the only dam in this study area. And I have another water storage somewhere here, if I can find it. Yeah, that's it. It's here. Okay. My other ROI is urban areas. So I will write urban and put the color of purple. Here I use the polygon option and start selecting ROIs. I get blocks of urban places in my study area like this. This process is more like a trial and error process, and there is no one way that can like work for all situations and all study areas. So you want to work hard on it and pay attention and consume time in order to have the desired results. You should change ROIs lots of times and lots of times and run the algorithm like tens of times in order to have the accurate map of classification. So that's enough for now, and I go to the next RI, and it's soil, and it's bare soil that there is no agricultural field and by some means no grasslands, but if you have like grasslands in all over, you can like say poor grasslands or poor pastures and something like this. But the bare soil in my study area is mostly in the mountains, so I collect ROIs in the mountain places. These are rocklands. So these are also bare lands and bare soils. And another thing you can do if you can't like diagnose the features with each other, and you can't understand which is which, you know what I mean, you can try different band combinations in here. Different band combinations show different features better. Here, if I write Landsat 8, so if I write here Landsat 8, band combinations, so here you can see the different band combinations for studying different features. For example, here false color often used for visualizing forest fire burn scars, rimfire, California 752. Or here you can see the 571 false color for vegetation and water. So it shows vegetation and water with better like diagnosis. So I will come back here and choose other ROIs in order to complete it. Okay, that's enough for the system. And I will go to the next ROI, which is Grasslands. Grassland, and I will show it in yellow and start making ROIs. Now in my study area, this place is mostly covered with grasslands. So this color, like you can see it here, here, and here, and here, these are grasslands. So I will collect them. Another trick in order to do this process better is to use Google Earth. You know, Google Earth has a very high resolution images, and you can sit and you can browse in your study area and see which is which, you know. You can see which features are covered in which places of your study area and go on. And like you know, lots of times you cannot visit physically the study area, but Google Earth has this option to like visit it by the internet. So another places I have grassland is here. You can see the color. These are like the delta of the river. So okay, and that's it. After you have collected all the ROIs, you want to save them. Go through it and right click, save as, and get the address and save it. And after doing all that, and after you made sure that you have just collected efficient and accurate samples and ROIs, you go to supervised classification, and you can see all these classification methods, supervised classification methods. The one that I love the most and I use the most is maximum likelihood classification. So you open it, and here the raster you open for the algorithm running is the layer stack. The image contains all these different bands. But why did we do it? Maybe you have asked. It's because when you want to run the algorithm gets the image you inform it to it. And if the image just contains three bands, like for the natural color, it doesn't it can't diagnose between different features you have defined in your ROIs. For example, I have said I have gardens mostly on my mountains in my study area. But if I just inform the natural color composite to it, it doesn't understand where is the mountain because it doesn't have the elevation, it doesn't have the slope, it doesn't have the dam. So we contain the slope in this layer stack in order to inform it better where is each feature. When it has the slope, it says, okay, this study area has garden mostly on the mountains, so it doesn't explore for gardens in the plain. So open it one more time and input file will be layer stack. Okay, classes from regions will be your ROIs, and output rule image, no, you don't want it, and enter the output class file name. It will take some time in order to complete the algorithm. Okay, you can see that this is the result image of this algorithm. If I compare it with the natural color I have, like here, you can see that maybe it hasn't done very well. But I said it's a trial and error function. Don't worry and do it times and times in order to have the desired image. So right now I opened the final image I got for this study area and for these images. I have done it before and I just want to open it in order to show you how you can prepare it in order to inform to SWAT model. As you can see, I have done it several times and the 30th one was the final image that if you compare it to the natural image, you can see that urban areas were these places, and it's pretty accurate. And the gardens are these places that it has classified it very well. And other urban areas which are in other places of my study area is classified very well. So when you have prepared this map and when you got to the desired result, you just want to go to data manager and you want to open, you want to have ArcGIS opened, okay? It should be opened, and select the image and click on open selected files in Arcmap. But here you get the error like Arcmap cannot run in 64-bit mode. So I should close it and open 32-bit mode. So no, I don't want to save them. Yes. Okay, open Envi 32-bit. And now open the same image I told you. Again, go to Data Manager and select it and select Open in Arcmap. When you go to Arcmap, you can see that it is opened right there. Okay, now I just remove all other layers in order to have it clean and neat and clean. So, okay, now you can see that this file doesn't have any attribute table. In order to make features out of this raster, you want to type raster to polygon. Raster to polygon, and input raster will be this one, field will be this one, and okay, and 13, save it. Okay, it made a polygon out of the raster, and you can see here it is open attribute table enabled. And in the attribute table, you can see that it has counted every single feature, and it has listed every feature into one field. You can see grid code 4444, but we want them integrated. So we use the dissolve command here, geoprocessing and dissolve. Select it, and input features will be the polygon, and output will be here, dissolve, and the dissolve field, we want to dissolve the field grid code. Okay, grid code, and press OK. Now you can see that if you go to open attribute table, you can see it's integrated, and the grid codes is number 1, 2, 3, 4, 5, 6, and the shape area, shape land, and all of them are organized and integrated into one field for each class. So the next step is to again use polygon to raster. Input features will be this one. Value field will be it can be both object ID or grid code. I will set it as default and object ID. Cell size, okay, optional, okay. Now you can see that it prepared a map that now you can have the value for each of them and the count. This is the number of cells. For example, this is too low and it's the water. The second value is for water and it's just 6 pixels in all the map. And that's it for today's video. This is the map you can inform to your SWAT model if you have prepared the lookup table. If you want more tutorial videos for SWAT model, let me know in the comments, and please subscribe to Arcmap Soft YouTube channel in order to understand where newer videos come up. Thank you for watching. Bye.